Good morning out there in VSP land. This is Rob McDonald. We just released version 3.2.0 of VSP with a ton of new features. I'm really excited about it. I wanted to make this short video just to show off a couple of the things. Hopefully I'll come back with some more in-depth videos down the road. First thing I wanted to show off was the new ability to support blunt trailing edge airfoils. So you can see I've got a normal wing here with a NACA root airfoil. And what I've done is I've come in and under the airfoil tab, we now have the ability to modify closure or trim that trailing edge. And so the option I've selected right here is to skew. So that's basically add a linear function to both the upper and the lower surface such that the trailing edge thickness is a desired value. So dimensionally, if you want that to be 1/4 of an inch, you just type that in and you have it. On the other hand, if you want to specify that in a relative sense, and you want that trailing edge thickness to be 2% of the chord, you put in 0.02. You can skew just the upper surface, the lower surface, or both, or of course none. In addition to skewing and modifying that surface, you can also trim the trailing edge to create a blunt end. And so if you want to trim in terms of some dimensional X distance or some fraction of the chord, you can do that. You can also trim to match a desired thickness. So say you want to trim that trailing edge until it's 1/4 of an inch thick, you can chop off the airfoil wherever that happens, or likewise specify that to say 3% of the chord. In addition to modifying trailing edges, if you read in a file airfoil that already is blunted, like this file that I have set up right here, VSP will now detect that the two trailing edge points are not closed, and it will treat them as blunt. If you have a model today that already has file airfoils, it won't do this automatically when you open it up. But if you go back in and reload the airfoil file that has those open trailing points, VSP will treat them as blunt. Of course, with this blunt airfoil file, if you want a sharp trailing edge, you can come into the closure and you can extrapolate that airfoil down to a sharp trailing edge. You can also then trim that thickness that you just extrapolated. So pretty much any combination of blunting, trimming, thickening should work for you. One thing to keep in mind is this airfoil. You'll notice that this sharp corner is now going to this sharp trailing edge out here at the tip airfoil. We do that by enforcing a certain parameter value here at the corner, and then we make that parameter value degenerate whenever there is a sharp trailing edge. So for example, if you want to add a subsurface line of the W type, and you'd like that subsurface to come right down at that corner, put in a parameter value 0.999, and that goes exactly at that corner. Likewise, if you want a subsurface on the lower surface, 001 is the value you want. Another great feature that we've added in this version is support for negative volumes in CFD mesh. I do want to emphasize that this is only a feature that really works in CFD mesh. But if I come in here and I want to make something somewhat resembling a engine pod, and I'm just doing this out of pods just to be quick and dirty, on the part that I want to be flow through, I can come in and on the general tab, I can now dictate that that is now a negative component. It now has negative volume. And so now when I come and I generate a CFD mesh on this component, that jade center body will actually become hollow. We'll punch a hole through and we'll be able to model flow through conditions. You can do this with any component in VSP, with anything going on at all. You'll be able to do that. Now mind you, this is only for CFD mesh. There is one other option, I suppose. If you're doing mass properties, you can always give the hole very high priority and assign it 0 density, and you will get center mass moments of inertia correct for something with a hole punched in it. But in terms of degenerate geometry, comp geom, those things do not support holes at this time. Another new feature that we've added is, and this time we implemented it with a custom component, is you'll now see a disk custom component. And that disk is just what you'd think. It's essentially an actuator disk. It has no volume, so it doesn't work with everything in VSP. For example, comp geom will just ignore it. But we did modify CFD mesh so that if you come in and you put in an actuator disk component, you'll see that it meshes, it comes in. It's a little bit hard to see because of that color of green. There you go. it meshes that face as a thin membrane, and that way some certain CFD codes will be able to work with that. Now, just to be interesting, we can also, of course, come in and put a disc and a wing together. And in this case, let's move this disc a little bit forward and a little bit span-wise, and maybe shrink it down a little bit. And let's tighten it back up against that wing. There we go. And make it symmetrical so that we have two discs. Let me come in and increase the resolution of that wing to improve that solution a little bit. We've improved the integration between VSP Aero for actuator discs so that when you generate that geometry and run the degenerate geom and then set up the input file, VSP Aero now automatically puts in some default propulsion elements read from the degen geom file into that model, so that when you now run the solver and we run our VSP Aero solution, we get a very, very quick and easy propulsion integration. And it makes it very easy to model aerodynamics interacting with an actuator disc. There's lots more features that I'm not going to have time to talk about today. But VSP 3.2.0, please check it out. It's really exciting. I did want to mention that we have a couple of new developers who've helped make this happen. Give a little shout out to Brandon and Mitch. Thanks a lot for all your help. And I hope to see many of you next month in Hampton, Virginia at the VSP workshop.